Lesson 6, permutations when objects are identical. So when there's objects that are identical, say you have two of the same thing, it doesn't matter what order you put those two things in. If they're exactly the same object, it's the same thing. For instance, if you had two cats and a dog, and you wanted to arrange it like this, it wouldn't matter that this is cat 1 and cat 2. If you're just arranging it cats and dogs, cat 2 and cat 1 would actually make the same order. So when there's identical objects, what happens is these two options actually just turn into one option because you don't want to account for multiples where their things are repeated. So for example 1, we have 4 Christmas ornaments, 2 are red and 2 are green. And we want to show how many combinations we could arrange them in. So if there were 4 different objects, 4 different ornaments, we would do 4 factorial, and that would make 24. So that would be if each object was different. But they're not, so we have to take into account the similar objects. So say for instance we start with our reds and our greens. We have 2 reds and 2 greens. It doesn't matter if you flip-flop those options, if this is red 1 and this is red 2. Or if this was green 1 and this was green 2. What that actually does is it takes rid of a large amount of options because we don't have to flip-flop multiple times. So we're just going to see how many times we can fit it, just alternating with the red and the green to see how many ways we could fit it. So what I'm going to do is I'm just going to rearrange the reds. So we could have the reds not together, and we could move the red over one more time to the outside. And now we need to start moving the first red so it would go over there. Then we could alternate green, red, green, red, and lastly we could have the greens on the outside and the reds on the inside. So really we have 6 different options. So we have to get from 24 to 6. And if you notice, the way that we get from 24 to 6 is to divide by 4. And we already know we get 4 factorial to be 24, so we have 4 factorial on the top. And what we actually do is we're going to divide by the repeated numbers. So 2 factorial and 2 factorial. And that's how we get to 4, which will get us to 6, which is our answer. So for example 2, you are arranging 9 different flags. 1 green, 1 yellow, 2 white, 3 blue, and 2 are red. How many different arrangements can you make? So we have identical flags here. So our total number of flags is n. I don't know, I drew the factorial. So there's 9 different flags. So we take our 9 factorial, we put it on the top. Now on the bottom we're going to divide by however many items we have repeated. So we have a 2 factorial repeated, we have for the 2 whites, we have 3 factorial repeated for the 3 blues, and 2 factorial repeated for the 2 reds. So when solving this, we always like to break it down. So on the top, that's the same as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we have 2 times 1 times 3 times 2 times 1 times 2 times 1. So we know that the 3 times 2 times 1 will cancel this out. The 1s don't really matter. And 2 times 2 is 4. So we are left with 9 times 8 times 7 times 6 times 5, which is 15,120. So that is how many arrangements are possible with these 9 flags, which is much less than if you could just do 9 factorial. So for example 3, we want to rearrange the letters in Canada, and we want the first letter to be N and the last letter to be C. So first, if there was no repeated objects, we have 1, 2, 3, 4, 5, 6 letters. So it would be 6 factorial, which is 720. That's a pretty big number. Now if we were to take into account the repeated numbers, we have the A's repeated 3 times, So we'd take 6 factorial and divide it by 3 factorial, which is the same as 6 times 5 times 4 times 3 factorial, divided by 3 factorial, and we know that these two will cancel. So we have 6 times 5 times 4, which is 120. Now it has one more condition, that the first letter has to be an N and the last letter has to be a C. So we have 1, 2, 3, 4, 5, 6. This is an N and this is a C. So we're left with 4 different options. So we have 4 factorial, we have an A, an A, an A, and a D. So we want to take that 4 factorial and we're going to divide it by 3 factorial, which is the same as 4 times 3 factorial divided by 3 factorial. These cancel. So we only have 4 options if the first letter has to be N and the last letter has to be C. So see how the conditions broke it down further and further. We started at 720, but because letters repeated, it went to 120. A big difference, and an even bigger difference when the first and last letter had to be something else. So that is how you would do this question. Example 4. Julie's home is 3 blocks north and 5 blocks west of her school. How many routes can Julie take from school if she always has to travel either south or east? Show in a diagram and using factorial notation. So if we were to take, if this is the house and this is the school, she can only go down and to the right. So if you were to go here, there's one way to get here. You can only walk down. There's also only one way to get here. If you want to get to this point right here, you could either go down 1, right 1, or you could go right 1, down 1. So to get to this point right here, there's actually only 2 options. To get to this point, there's only one way, 1, 1. There's no other alternative routes you can make. Same to get to this point right here, also a 1. To get to this point right here, there's multiple routes you can take. You could go 1, 1, down, that's one route, 2 routes, or you could go down and across. That's 3 different ways to get here. If you wanted to get to this point, you could go down 2 and over, which is 1. You could go down and around, which is 2, or you could go right then down, which is 3. So notice there's a little bit of a pattern going on here. To get to this point right here, there's only one way. You can only go straight down. Same with here. You can only go straight to the right. And it's the same all the way down the block. To get to this point, however, there's 4 different ways. You could go down, 1, 2, 3, 4, or you could go 1, 2, 3, 4, that's 2 ways. You could go like this, 3 ways, or you could go right first, then down. So there's 4 different ways. This is where you should be able to see the pattern. To get to this point, you could go to the right twice, 1, 2, then down twice, 3, 4. You could go to the right once, and then down, 2 ways. You could go down, then across, 3 ways. You could go down, across, 4 ways. You could go down, down, across, 5 ways. And you could also go across, down, across. So there's 6 ways to get here. And the way that you can figure this pattern out is if you add this number and this number, it'll get your next corner. Same with here, you add these 2 numbers to get 4. These 2 numbers to get 4. So you can fill the pattern as you keep going in. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. 20 plus 15 is 35. 15 plus 6 is 21. And 35 plus 21 is 56. So there's 56 ways you could walk to school. That is one way to do it. Another way to do it is to imagine you have 1, 2, 3, 4, 5 blocks east to go and 3 blocks south. So in total, you have 9 blocks to walk. So we have 9 factorial, but we have to divide by the ones that are multiples. So we have 5 factorial and 3 factorial because we have 5 easts and 3 souths. So we're going to take that 9 factorial, and by 9 I mean 8. I counted this S. Nicely done. So we take our 8 factorial, divide by 5 factorial and 3 factorial. So we have 8 times 7 times 6 times 5 factorial divided by 3 factorial times 5 factorial. Always go with your biggest factorial to cancel it out. So these two cancel out, so we're left with 8 times 7 times 6 divided by 3 times 2 times 1. 3 times 2 makes 6, which cancels this. So we have 8 times 7, which is 56. So either way, however way is easiest to you, following this pattern or doing this, it's all good. Also, this is called Pascal's triangle, in case you didn't know.